All right, this is our second installment of the circuits videos. In this video, we're going to talk about Ohm's law and how it relates to the power of an individual circuit. There are a couple equations that we're going to learn in today's videos. Our first one is Ohm's law. So Ohm's law says V equals IR. More importantly, it's written I equals V over R. This is just a real easy way to remember it. And as we get further down the road, we're even going to say delta V equals IR as we get further into circuit analysis. But right now, the best way to learn it is that the current in any particular circuit is equal to the voltage supplied to that circuit by the battery divided by the total resistance of that circuit. Right now, we're dealing with simple circuits. I just have my 12-volt battery over here, and I have a 24 ohm resistor. Alright, so the current is going to leave the positive terminal, come around here, go through my 24 ohm resistor, and then come back to the negative terminal of the battery. So how much current do I actually have flowing through my wire? Well, it's determined by this resistor. If I have a high resistance value, that means that only a couple of electrons are going to be able to go through. But if the resistance is really low, then the current is going to be high. So they're inversely proportional to one another. So in order to solve, it's just 12 volts divided by 24 ohms. That's going to give me 0.5 amps. Current is measured in amps and its symbol is I. None of those three things go together, so just get used to it. Makes no sense, like the rest of physics. Alright, our second equation is power is equal to the voltage multiplied by the current. Alright, so there's a lot of different ways to solve for power. The standard one is just VI. If we remember Ohm's law from one slide ago, the voltage of a circuit is equal to the current times the resistance. So now I have two equations, so I can start to substitute some of the values in. So we can rearrange Ohm's laws in different ways, substitute in for the power equation to solve by using different variables. Sometimes it's even easier to solve. So in the end, we get P equals I squared times R, or P equals V squared over R. So we're just rearranging Ohm's law over here, plugging it into what used to be V, or solving for I and then plugging it in there. So, all right, let's look at a particular problem. All right, so what is the power supplied to a 50 ohm light bulb attached to a 10 volt battery? All right, so once again, here's my current. It leaves the positive terminal of the battery, goes through my resistor, and then ends up at the negative terminal. All right, so here I have a voltage and I have a resistance provided. Our standard equation, P equals VI, wants me to solve for the current. Well, I could do that. It's not too hard. I equals V over R. So 10 divided by 50. So I equals 0.2 amps. Now I can go back and say 0.2 times 10. So P equals VI. So 0.2 times 10. So 1/5 of 10 is going to equal 2 watts. Or if I just wanted to solve it in one easy scenario, I could have used this one down at the bottom. This way I don't even have to solve for current. So this is just saying voltage squared. So 10 volts times 10 volts divided by 50 ohms. 10 times 50 is, 10 times 10 is 100. Divided by 50 is also 2 watts. So everything checks out. I get the same answer. So it's just giving us an alternative way to solve, an easier way to solve, so that way we don't have to go through everything and we can solve faster, which is what we're always looking to do. All right, so that's that.